Okay, now let us take a look and see how we can analyze categorical data against our, in this case, our potential target numeric data. All right, so you can see we have here a chart that indicates, well, we have charges over here on the right. That's our target variable. We've got a number of different predictor variables. So we've done our numeric by numeric scatters, but we have several categorical variables. First, we have biological sex here, which is one of two values, male and female. Same thing with smoker. We have smoker yes, smoker no, two groups, but then we get to region and we have four groups: northwest, northeast, southwest, and southeast. And we could see in the connectors up to the top of the diagram that we have different types of tests that we can run. So for numeric, we ran a correlation, looked at our trend line, figured out which kind of trend line and linear equation works best. Now we're going to perform a different type of test. So when we have two groups, we can run something called a t-test. Many of you may have done this in your earlier stats class. And we've got a couple different ways that we can run the t-test, which we will explore. Now, we have four groups in region. And we could approach that by also performing t-tests against each possible pair of categories in that variable. Or we can run what's called an ANOVA, analysis of variance. A one-way ANOVA will allow us to simultaneously compare mean values for all four of the groups at the same time within the same calculation. All right? And here's what we're looking at when we're trying to perform a t-test. Basically, we've got a distribution of values across each category, in this case, smoker versus non-smoker. What we're trying to do is determine, are the means and those distributions different enough to be statistically significant, or are they close enough that we would not be able to assume they're separate and say that, well, we'll have to accept the null hypothesis that they're the same. And you can see here, the way the t-test is calculated, we just calculate the difference of means, and we're going to divide that by the square root of the standard deviation squared of group 1 over the count, or the n of group 1, plus the standard deviation squared of group 2 divided by the n for group 2. All right? The second thing we can determine is whether we want to run a one-tailed or one-sided t-test or a two-tailed test. And in exploratory data analysis, if we don't have any reason to hypothesize one way or another, we would go with a two-tailed test. If we do have some kind of prior coming in that we can work with, for instance, smokers tend to have higher healthcare costs, we could then use a one-tailed test or a one-sided test. Now, ANOVA works pretty much the same way, only we're calculating all the differences simultaneously. We're looking at the differences in means and mean differences across the groups, and then we're also looking at the variances within the groups as well. For the most part, we can think of it as being similar to that t-test. We use something called the F value over there to determine whether we have an overall difference between groups, and then we can also still evaluate each group independently. So here's what we're trying to look at when we do an ANOVA, is we're looking to see basically a similar concept, only with more groups within our category. Are these groups different enough from one another to be considered statistically significant. So how do we do that using our tools? Well, the first thing we might do is we'll probably start by visualizing the data. So we're going to start a new page, and we could say we're going to create a bar chart or a stacked column chart. And in it, we're going to include one of our categorical variables. We'll start, let's see, let's start with sex. So we've got male and female. And then we've got charges. Now in this case, we see overall charges by sex. I don't want to see the sum of charges because I may have a different number of male data points than female data points. So what I'd rather see is average charges. And here we can see almost 14,000 average charges for male. Looks like about 12.5 thousand for female. Now the question is that significantly different? Now we could create some complicated calculations within Power BI and determine that. We could actually create a measure for that. But instead, and so I'll go ahead and change this to charges by, well, we'll do a sex bar chart. So let's see how we can do that in Excel. Okay. So the first thing I'm going to do is I'll go ahead and copy this worksheet. Actually, you know what? I'll just copy the data itself because I have these charts. So I'll copy columns A through G. And then I've already created a correlation matrix here, so I will create a new sheet and paste the data I just copied. And we'll call this category analysis. So the first thing I might say is, okay, so I've got category analysis. I also, it retained my table features when I did this, so I can now start filtering. Let's say I want to filter by sex, so I'm going to filter and we'll start with just the females. So I'll select females only. And then I'll put a column over here that I call female and male. And I'll copy and paste the charges that show up in that filtered view. Starting with female. Paste values. And I can see that takes me down. Well, I don't really have a good count because I'm skipping a number of rows. Based on my filter. So now I'll uncheck female, check male. And I now have a different set of charges showing up. I'll copy those, and it looks like I have more males than females. So now I can perform a t-test. And I've got a formula in Excel that allows me to do a t-test. But I have installed the data analysis tool pack, so let's use that instead. So I'll go to my data tab and I'll click on my data analysis tool pack. And you can see I have 3 different types of t-tests. First one is paired two-sample for means. Well, I don't have paired, basically means you have to have the exact same number in each category or each group that you're analyzing. We can't guarantee we're going to have that, so we're going to eliminate that as one of our potential t-tests. The other one basically goes into your underlying assumptions. If you have some reason to assume that your variances will be equal or otherwise, you can use one of those 2. Both tests are going to give fairly similar results. A little more robust approach is to assume unequal variances. So we can do that. And now it's just going to ask, well, where are the 2 ranges of data that you want to evaluate? So I'll select the female column first. I'll select the male column next. So there's a small difference, but it wasn't as big as I thought. We'll say our hypothesized mean difference is 0. We do have labels on our first row. And instead of creating the output in a whole new worksheet, we'll just create it right up here to the right of where we are. We'll move it over here, let's say to column Y. Okay, so we now get our t-test two-sample assuming unequal variances. And we can see the p-value is significant, but it's not as gigantic a p-value as we might expect. And when we looked at the bar chart, that makes sense. The values were reasonably close. Okay. All right. So, some marginal significance here. What about smoker and non-smoker? Well, we'll do the same thing here. And if you're if you're thinking ahead, you could probably figure out what we'll do next. All right, so let's flip back to Power BI and see what our smoker chart is going to look like. Now, in this case, remember, I'm just on the sums. It looks like we're pretty close. Or let's change that charge value to the average. And now you can see, yeah, that looks like there's a huge difference. Let's see how that translates to our t-test. So now, before I start working with smoker, I want to make sure that I take away all the filters I've got on my sex column, and now we'll work on smoker. Smoker, yes. Smoker, no. And we can run a t-test on that one. One thing to keep in mind when you run your data analysis toolpack options, they often will remember what you did last time you used them. So it's important to clear things out and put your new values in those ranges. So variable 1 is going to be M, variable 2 is going to be N, and I want to make sure that I change where the output goes to a new location, Y18 in this case. And I click OK. And you can see there's a pretty good difference in the number of observations for smoker and non-smoker. The T-stat is huge, 32 versus negative 2.144. So our P value is a lot bigger now, or a lot more significant. So actually way smaller. 2.7914, times 10 to the negative 103rd. So a ton of zeros before we get our first significant digit. So we can feel pretty confident that we've got ourselves a significant difference there. What about region? Okay, so region, what we're going to do is we're going to do the same thing, only we're going to have to make 4 groups this time, 1 for each region of the country. So we'll remove our filter from that. So we'll start with Northeast. Now we'll go to Northwest. And Southwest. So as we remove all the filters, what we can see is that there were a couple blanks in there that got thrown in as we had the filter showing different numbers of rows. That's going to be okay for our analysis because our test will ignore any of the missing values. But if you want to be sure, you can just remove all your filters, highlight those cells and press Control-, and that will allow you to shift your cells up and remove all those gaps. Okay, so at this point, we're ready to run our ANOVA, which we're going to do for our region category, which has the 4 different values. So going back to our data tab, I'll select the data analysis toolpack, and I'm going to choose a single factor ANOVA. My input range, now at this point I select the entire range all at once. And here I'll need to make sure I get to the bottom of all of my most populous range. I do have labels in the first row, and I want my output range to go back in my worksheet. Same worksheet. And we'll put that right here where I had my cursor. Click OK. And I now have an ANOVA of my various groups, along with each group's average value, variance. We can look and see that I've got an F value of 2.969, which is a p-value of 0.03. So again, pretty significant. And we're not at the huge upper ranges of significance, where we would say this is wildly significant, but it's pretty significant. Okay, so definitely worth investigating further. Now, to take this a little bit farther, we could then supplement this with a t-tail test, or a t-test for each group within the ANOVA. So Northeast versus Northwest, Northeast versus Southeast, Northeast versus Southwest, and so forth. All right, so this is smoker bar chart. And we'll finish up our visualization by adding a region bar chart. And again, we'll have to change our charges from the sum to an average. And at that point, we're ready to start updating our documentation just like we have before. Data exploration, and add to where we've just put our scatters and our analysis of the scatters and their corresponding trend lines. And now start adding our categorical variables, our categorical potential predictors, our bar chart analysis of these, as well as our t-test and ANOVA analysis. And then we'll interpret what that means, write that up briefly, and determine whether we'll move further with that particular variable or not. All right, so that takes us through categorical by numeric analysis. Let's pause for now, and we'll get back in the next section and take a look at categorical versus categorical.